In this example, we're going to justify why subtracting an integer from a number is the same as adding the integer's opposite to the number. This is going to be a really useful fact for us when we're adding and subtracting integers. So we're going to do this with an example, but my hope is that you'll see that this can generalize to any two numbers. Justify that 5 minus negative 3 equals 5 plus 3 using integer chips. I'm going to start with 5 plus 3. And remember, when we had addition, we took our first amount, 5 positive chips, and our second amount, which is 3 positive chips, and we combine them into one group. So I'm just going to circle them to show that we're combining them. And this gives us a total of 8 positive chips. So we have 8 positive chips. So how does this relate to 5 minus negative 3? Well, remember, with subtraction problems, we start with the first amount, which is 5. And then we wanted to take away 3 negative chips. We didn't have any negative chips to take away, so we decided to add 3 positive and negative pairs. So adding these 3 positive and negative pairs doesn't change the value of 5. And now we have 3 negative chips that we can take away. So let's circle the chips that we're going to take away, and what remains is the 8 positive chips. So again, we're left with 8 positive chips. So how this connects is we start with the same amount, in each case 5. Okay? We're trying to show that subtracting an opposite, so subtracting negative 3, is the same as adding positive 3. Well, when we added positive 3, that gave us 3 more positive chips. Subtracting negative 3, we were forced to add 3 pairs of positive and negative chips, and we took away the negatives, leaving 3 positive chips in our minuend. So these two expressions are equivalent, and now we can use the fact that if we want to subtract an integer, we can change the sign, the operation symbol to addition, and change the sign of the second number.